Hello, brilliant minds, and welcome to Coded Universe, your portal into the vast realm of programming. We're about to embark on a journey exploring polymorphism, a fundamental concept that transcends the boundaries of code and finds its place in our everyday lives. Stay with us as we unravel the mysteries of this principle. And remember, if you find our cosmic expedition enlightening, ensure you like, comment, and subscribe to stay part of our Coded Universe. Imagine a chameleon, a master of adaptation. This remarkable creature has the ability to change its color to match its environment, allowing it to blend in and adapt to a variety of situations. Now let's relate this to programming. In the world of coding, we have a principle known as polymorphism. The term itself comes from Greek words poly meaning many, and morph meaning forms. So just like our chameleon friend, polymorphism is all about taking on many forms. It's the ability of a function or an object to behave differently in different contexts. For instance, a single function or method could perform different tasks based on the type of input or number of arguments. This dynamic nature is what makes polymorphism a core concept in object-oriented programming. So, in essence, polymorphism in programming is quite similar. It's the ability of a function or an object to take on many forms. First up is compile-time polymorphism, or what we call method overloading. Now let's take a trip to a hardware store. We see a variety of tools, each with a different purpose, but they all have one common name: tool. A tool could be a hammer, used to drive in nails. The same name tool could refer to a screwdriver, used for tightening screws, or it could be a wrench, used for bolting objects together. Just like a chameleon, the term tool adapts based on what we need it to be. Each tool carries out a different task, yet they all share the same name. This is the essence of compile-time polymorphism, or method overloading in the programming world. We have one method name that can perform different tasks depending on the context. When we write a method in a program, we can write it in such a way that it behaves differently based on the input it receives or the number of parameters it takes. This provides flexibility and allows us to reuse the same method name for different functionalities in different contexts. So, method overloading is like a toolbox with a variety of tools, each serving a different purpose, but all sharing the same name: tool. This is like method overloading, one method name with different functionalities chosen based on the context. Moving to runtime polymorphism, or method overriding, let's turn our attention to a familiar setting: the kitchen. Picture this. You're preparing a beloved family recipe, one that's been passed down through generations. Your parent or grandparent has a set way of making this dish, and you've learned it by heart. But when it's your turn to don the apron, you add your own flair. Perhaps you toss in a pinch of an unexpected spice, or drizzle a little extra olive oil. The name of the dish remains the same, yet the flavor profile changes slightly with your personal touch. In the world of programming, this is akin to method overriding. When a child class shares the same method name as its parent class, but exhibits a different behavior, we say that the child class has overridden the parent's method. The method's name stays the same, but its implementation varies depending on whether it's invoked by an object of the parent class or the child class. Just like your rendition of the family recipe, the child class puts its own spin on the method, while preserving the original name. This allows for a more dynamic, expressive programming style, where objects of different classes can respond differently to the same method call. This mirrors method overriding, where a child class overrides a method of its parent class to perform its unique action. In essence, polymorphism allows for flexibility and reuse in programming, just as a chameleon adapts to its environment, or a single tool can have multiple uses. We've explored these concepts without writing a single line of code, but by connecting the dots with real-world parallels. If this cosmic journey intrigued you, don't hesitate to show your support. Like this video, share your thoughts in the comments, and subscribe to Coded Universe for more enlightening explorations. Until next time, keep coding your world.